Swayam Prabha. Digital India. Educated India.
Welcome to today's lecture, Design Analysis of Orbit Motor. This is lecture 1 on orbit motor, where we shall discuss about basic design and feature, and this is under the module 8, which will cover some special topics on hydrostatic transmission unit and system. Now, already we have discussed that large power transmission in tight space and their control with exceedingly rapid response for military, industrial as well as modern applications such as robotics requires motors with very high torque to inertia ratio. The fluid power units in general, which possesses such characteristics with several orders of magnitude higher than what can be obtained from other conventional units such as electrical motor, hydrokinetic units, etc. And these are still holding the top rank in the field of application in spite of their relatively high cost. Furthermore, there are low speed high torque variety of hydraulic motors, which makes the HST compact, very compact in comparison to the HST with the general high speed low torque HSLT motor. The orbit motor is a low speed high torque hydrostatic unit. In this lecture, we shall learn about the working principle and the basic geometric design of the star and ring set of orbit class of machines. In these machines, the output torque is augmented due to epicyclic gearing action of star and ring gears. Now, at first look into two different units following same kinematic principle. This is to understand how the orbit motor works. Now, this is harmonic drive, where what we find, the outer member is fixed, inner member which is a flex gear, it is rotated by a cam, and if we very slowly observe, very closely observe, then what we will find that this flex gear is rotating at a very slow speed. In turns, it is transmitting very high torque. The ratio is nothing but the teeth number in the flex gear divided by the difference of the teeth, in this case which is 2, and suppose there is 100 teeth of flex point, then in a single stage we get reduction of 50. Now, another machine which is Wankel engine, here we observe that more or less similar pattern of motion. In this case, what we find that inside like a triangle, which we can call 3 lobed or 3 teeth is rotating inside another somewhat oval, and if we observe, it is having 2 lobes, the identical. If we draw a vertical line, the right hand side will be identical with the left hand side. That means this is a 2 teeth, here inside 3 teeth, outside 2 teeth. This is also a gearing action, the inside gear for the transmission, forget about this part. But what we find that this space is increasing and decreasing, it is expanding and compression mode, and you can imagine that in one chamber the fuel is being injected, then this is being the ignition and then the combustion, and it is going out. In that way the Wankel engine motion is available. Now, with this Wankel engine, if we compare, we can think of the machine which we shall discuss today. I shall discuss today, that is orbit motor. But here what are shown, that there is an inside member and there is an outside member. The inside member is called star and outside member is called a ring. Now, in comparison to this Wankel engine, if we compare with this Wankel engine, here is also the similar motion is possible, and we will find that the chamber between these 2 contacts and the space is going compression and expansion. So, this also can be used as an engine or maybe motor. Also, if it is in this case, what we find, the outer member is fixed, inner one is rotating. Okay. In this case also, if we do it like that, then we will find the similar action, but the difference is that in this case outside 2 lobe, inside 3 lobe. In this case, what we find, outside 7 lobes, inside 6, 1 less, in this case 1 more. I shall come later in why it is like that, but let us see what is happening there. Now, look at this. This is in the same fashion, it is rotating what is in Wankel engine, or what even in the harmonic drives also, and we find that this space is going under compression and expansion. So, we can think of that we can pump out the oil, but later I shall explain that using this as a pump unit is not beneficial. Rather, if we allow the high pressure oil to come in like an engine, and then if this is rotated, we will get both motor action as well as gearing action, and which will give us the high torque low speed machine or low speed high torque machines, which is called orbit motor. However, it is also possible if we keep these 2 axes fixed and allow the outer member also rotate when the inner member is rotating. In that case, this expansion will be also, expansion and compression will also be there, but the output will be at higher speed, which is termed as G rotor units or G roller units, and in that case this will act as a high speed low torque hydrostatic unit, which is motor or pump. Now, here I have explained that these are the chambers, this is between these 2 contacts which are active contacts, and this roller. This space is an area, variation of area multiplied by the constant width will give the variation of volume. Now, this profile is called epitrochoid, it is modified epitrochoid, whereas this profile, the outer profile is called envelope, and this is ring and this one is star. Perhaps this is a slightly displaced, but you can understand easily. However, this star which is in epitrochoid, the ring will be envelope of this. Now, here what is shown, if this is the epitrochoid which is not modified, this we should consider as modified, and this one is not modified. Now, if the same motion is generated of this profile, then we will find that this will generate a profile either like this or like this. How? If we make this one as a solid cutter, then we will find it will make a profile like this, which is actually envelope. Motion is same as like this, what you have seen just. Or if we make this is a hollow cutter, do you understand? So, let us consider a cylindrical body and inside shape is like that, this portion is hollow. In that case, this will generate a profile like this. Now, what is there? If these points are called node, in that point if we fix a circle, then what will happen? Fixing this circle and taking say either outer one or inner one, anything, only let us consider this circle. This circle if we allow to rotate, give the reverse motion, then we will find a profile which is parallel to this, just like this, I mean parallel to this inwardly shift profile. Okay. So, this profile is the star profile, whereas this rollers becomes the envelope of this. So, it is not easy to grasp just from a single lecture. If you read it, then you will be able to understand. You have to visualize this. Anyway, in that way these profiles are generated, and this is a very simple machine, but very effective to give high torque at low speed. Now, in this case we have named Zg is the lobe number or say teeth number of the ring gear, and Zp is the lobe number of the star gear. We can call it gear. This is outer one gear and this is pinion. What we find in this case, inner one is 6, outer one is 7. Now, these two numbers should be consecutive number always. If this is 7, then 8, but making this is 8 and this is 7 means number of chambers will be 8. So, even number which is not benefited. So, always you will find that ring gear lobe number is 7, 9 or 5, something like this, whereas this is even number, one less than the outer member number. Okay. Now, let us see this working principle. The first case we shall study the ring gear fixed, star gear as input. Now, these two circle, these are we should call base circle if it is in terms of involute teeth. If it is of other teeth, usually this is called describing circle, say cycloidal teeth. In that case, it is called describing circle. What I have mentioned, the teeth are here, the epitrochoidal teeth, which is from the family of cycloidal teeth, and this motion is called cycloidal motion. In that case, the outer one is the describing circle of the outer member, that is in this case envelope. ring gear, and inner one is the describing circle of the inner member, that is star member. Or if we compare with the harmonic drives, then this is the base circle or the describing circle of the flex gear, the outer one is the base circle or describing circle of the outer gear, the ring gears. Now, we have taken these two describing circle, which you can consider the drum, equivalent drum. Even if this you may consider the pitch circle, pitch drum of these two gears. So, this means that whatever motion we have observed, whatever motion we achieve from these gears, that can be shown by two friction disc. One is the hollow one and one is the solid one. And if we consider the slip level motion, it will show the same motion as in case of orbit motor or harmonic drives. Now, this is the ring gear, representing ring gear, and what we have in the we have taken this case, the outer gear is fixed, ring gear is fixed, inner gear will rotate. Now, this outer one is the star gear. Now, next imagine the arm. Okay. So, this arm means on a single plate you can say that this is pivoted, this gear is pivoted here and this gear is pivoted here. Now, what we do, we consider 2 points on these two gears. Now, in next phase what we do, we give the whole unit a angle by phi, this angle motion. Okay. So, what will happen, these 2 points are here, these 2 points are here, and next moment what we do, we bring back this point to here, keeping this arm fixed. What we do, we just simply rotate back this point to here. Now, this means that this gear again is rotating in the opposite directions, anti-clockwise direction by the same angle. What will happen, the inner one has to rotate by this much angle. What is that? This is Zg by Zp, which is equivalent to their radius R2 and R1. We can put R2 is equal to Rg, R1 is equal to Rp. So, that ratio is this one. What we can see from here, why this is rotating in the opposite direction, this has to rotate also in this direction, and this arc length and this arc length has to be same. And if you equate, we will find that this gear has rotated by this much. Okay. So, as we have taken back this point to its original position, we can say the net rotation of outer one is equal to 0. Okay. Then what we find, that the first action which we have given is the coupling action, and the second action is gearing action. That means, what we have done in this phase, that is the gearing action. In case of all such machine, you will find that gearing action is actually happening in the opposite direction, and it is happening simultaneously. So, we have to consider when we are going for the gearing analysis for the gearing portion, which one is driving and which one is driven, and where is the contact. To analyze this, we must understand these two actions. These two actions simultaneously giving the action of harmonic drives or gearing action in orbit motors. Okay. Now, to find out what is the transmission ratio, what we do, divide rotation of whole unit about central axis by the net rotation of inner one, net rotation of inner one. And equation wise what we will find, we have first given these rotations. So, this we can consider the input, and this is the net rotation of this unit inner one by its own axis. First it has rotated in this direction by this angle, and next its rotation by this angle in the opposite direction. So, difference of that is the net rotation of this one. So, this is definitely giving the speed ratio. If we equate further, we will get the transmission ratio, which is equal to Zp Zg minus Zp. So, this is the difference of the teeth number, and this is the teeth number of the star, and minus sign is coming due to the fact that while the input in clockwise direction, the output will be in the anti-clockwise directions. So, this is the total transmission ratio what we will get out of this pinion, the star member, which is the output of the harmonic drives which I have shown, and the output of the orbit motor which I have shown. Okay. There is another, okay, this what I have shown here, these two falls in the same category. Okay. Both the orbit motor, these harmonic drives falls in the same category. Now, another possibility is there that we can keep the inner member fixed and output is taken through the outer member. Now, the arm is as you have seen. So, we have to definitely this will be the central axis. In that case, what we should consider, the rotation of the inner member, star member about its own axis is restricted. That means, it is not allowed to rotate about its own axis, whereas this can wobble like this. This is possible because imagine a the cardinal shaft or universal joint. Now, holding the universal joint, you can rotate the other member like this, which is not allowed to rotate about its axis. So, this motion is possible. Now, here what we have done, like earlier case, we have again taken these 2 points. In this case, what we have done, the inner member we have brought it back to this position. So, outer member has rotated by this much angle, Zp minus Zg by into phi. This means that R1 by R2 by phi. Okay. So, definitely this angle must be less than this angle, because this arc length, when it will cover on this larger circle, it will rotate by smaller angle. This is, as you see, this almost in a line. It is not that this will rotate slightly in these directions, but ultimately this motion of the outer body will be in the clockwise direction. So, we can consider this is fixed. Fixed mean rotation about its own axis is arrested. Okay. So, this is rotating in the same direction, and the transmission ratio, if you derive, it will come as like this. So, this is the transmission ratio of this one. In this case, what we find, at the numerator, the number of lobes or number of teeth of the outer ring is there, and at the denominator the difference is there. And in case of orbit motor, you find that difference is always 1. So, if this is 7, this transmission ratio will be directly 7. Okay. And in case of harmonic drives, you will find this difference is 2 normally. So, if it is 100, then this will be 50. So, as in first example I told that this ZP is 100. So, this is 102. So, this will be 51. Okay. Now, Wankel engine falls in this category. This means that actually this here, what is the inner member, what we are looking here, that is basically the outer member, or I would say that base circle of this is larger than the base circle of this one, the outer member. How it is possible? This is possible if we cut the material by the opposite cutter. I have told you that why we are generating envelope using, once we using that cutter as a hollow and solid. If we make this cutter as a hollow, then inner member will be the envelope, and envelope will have one lobe more than the outer member. Wankel engine is generated in this way. However, it is not complicated, but just cumbersome to grasp in a single lecture, but you just remember this thing. That is why I have shown here. This Wankel engine falls in this type 2 category. Okay. Now, before going into the orbit motor, what we see this, what is the working principle kinematic I have shown. In that category, the harmonic drives is there, orbit motor, that is also falling in the same category. Then there is another machine which is called cycloid speed reducer, that also falls in the same category. Basically the cycloidal speed reducer and the orbit motor principle and tooth generation are more or less same, only this here the planet carrier is different, because the torque is transmitted through the planet carrier. Also with the solid gears, not harmonic drive, with the solid gears we can have another gear drive which is called planocentric drive. This looks alike. Here what I have shown, that bottom portion I have shown the cycloidal, and the top portion I have shown the planocentric drive, and this planocentric drive and this drive is same. Only thing in this case we are using flex gear, because we making the gear flex we can go for 2 teeth difference, whereas in this case we cannot go for 2 teeth difference, minimum 4-5 tooth difference will be there. Anyway, that is different issue, we are not going into that, but the kinematics which I have explained, that all such machines fall in the same category. Okay. Now, axial or radial piston cylindrical machines are termed as rotating piston machines. Rotating piston machines. Okay. Just this term is not very common. We are not. It is not very popular term, but still we can say rotating piston machines. Say engine is a rotating piston machines. In such machines, in a piston cylinder, the piston area remain constant, and the variation of volume occurs due to change in stroke length, while the piston is given a motions. Contrary to that, in another version, a geometrically form closed area varies with the rotation of either or both elements. Comparing with piston and cylinders, the variation of the volume which is constituted by that area and a constant width in transverse direction is due to the variation in area only. This means that what the machine we are new machine in comparison to that we are talking about, that variation of volume is equal to the variation of area into the constant width. So, if we equate the time variation of the area that will give the volume displacement of the machines for a unit area, unit width. Such machine is termed as rotary piston machines, which is called as ROPIMA. Now, this ROPIMA term is not normally known to people, but Wankel engine, I think Wankel he himself put this name, rotary piston machines. Contrary to the rotating piston machines, this is called rotary piston machines. Now, Wankel like Wankel engine, orbit motor also falls in this category. Okay. So, this is the view of an orbit motor, which I am going to explain now. Now, in this orbit motor, what we find that, let us look again what is happening. So, this is the rotary motion which we are taking as an output, but this is being rotated by allowing the oil, high pressure oil to come in. Okay. Now, with respect to that, if we look into these machines, so this is the star member and this is the envelope, the lobe member. This member can be integral part or we can use separate roller. Now, what is there? This star is connected to a shaft by a joint which is called Cardan joint, Cardan shaft. This is principle wise it is same as the universal joint, only in this case this is two gear coupling at two sides. One is inside this shaft, another is on the star. Okay. Now, this shaft is integral with a flow distributor valve. In that valve, what we find, I shall describe the valve function later a little bit, but at this moment just look at this. The oil is coming through the outer body to this pocket, then there are few slots on this shaft, on this valve, and through this slot it is going inside the chamber. The passage is allowed to oil go into this chamber, and this oil will go only when this is in the expansion mode, and when it is compression mode the oil will come out through this passage and it will go out. So, in this way this motor functions. Okay. Here what I have shown that this is a cylindrical lobe which also can be made integral one. Two possible variety out of these star and ring. One is that fixed axis gerotor or G roller, high speed low torque, hydrostatic transmission unit, which is pump or motor. In this case this axis is fixed, this is also fixed. Usually what is done, say a shaft is connected here, the shaft is being rotated and this is also allowed to rotate about its another body, and then you will find these chambers are varying. We need not Cardan shaft in that case. Okay. Usually you will find the outer member, in that case gerotor or G roller remain fixed, and then this can be used as a pump and motor, because motor action is just reverse action of the pump. And if we ask then orbit motor, why it is not used as a pump? You see, this is basically high torque low speed machines. Now, if we would like to use this as a pump, for the same pumping action we have to transmit very high torque at low speed. Say using a engine means that engine we have to, maybe we have to use a reduction gearbox to run this as a pump, which is not benefited. So, usually this version, this epicyclic motion version is always used as a motor. It can be used as a pumping action, but the different applications. Say for example, when this unit used as an orbital steering unit, then a pumping action of this is also used there, but that is different issue. In normal case, this always as a motor. So, this version, the second version is the floating axis. Actually, this is an epicyclic gearing action is there, epicyclic motion is there. This axis, why we call this is a floating, because this is not in true sense not rigidly connected to any shaft, because this motion of this guided by these contacts, which is form closed. This is called form closed. Always theoretically these points are with full contact, no gap in between, neither it is a interference fit, it is an interference fit. Okay. So, two possible machines are possible with this arrangement. Now, with this figure, in this case it is a 6-lobed inner member. So, this is described, the 6-lobed inner member is made to rotate in epicyclic manner while the outer member remains fixed. The form closed spaces, the term is form closed, the spaces between separated by active contacts, these contacts are called active contacts, constitute chambers. Outer member has 1 lobe extra, in this case 7 lobe. Also there are total 7 contacts, 1, 2, 3, 4, you will find that there are 7 contacts, and this machine has 7 chambers. In motion, the above mentioned spaces experiences change in areas, and thereby the chambers experiences suction and compression. Two motions of the rotor are observed. These are revolving of the rotor. Rotor means in this case star about the central axis of the stator. Stator means in this case ring gear, which happens to be usually the central axis of the whole machines. That means the central axis of the outer member is the central axis of the whole machine. Rotation of the rotor about its own axis. This member is having a revolving motion around the central axis, and it has a motion about its own axis. Analyzing this motion, gearing ratio and the torque multiplication, that is transmission ratio, can be found as already described, that when the ring fixed star output, the type 1, the transmission ratio is the number of star member divided by the difference, and when the star fixed and the ring is output, then the number of lobe of the ring divided by the difference. Only here this is a minus signs, that means these two motions, one is the revolving action and the output motion is in the opposite directions, where this is a plus sign means the revolving action and the rotation is in the same directions. So, this is the orbit motor type 1, which we have seen already, but still let us observe 1 second. So, this is the motion already which you have seen, this is normal case orbit motor. the outer member is rotated by holding the shaft. You can, if you hold the shaft in this case, only thing you have to think of the oil connections, and you will find the outer member rotation you can use. That type of machine is also used where the rotation of the outer member is used, say for example, big merry-go-round, in that case it is used. Okay. Now, let us consider the flow distributor valve, how it is working. What we find that this we have taken 6 number of lobe for the star member, 7 number of lobe of the ring member, and what we find, say this is the distributor valve, this is the valve come the output shaft which you have seen in the machines, and then if you observe that these grooves are this groove, we have taken this section are this groove. So, alternative grooves are connected to these 2 slots. If one is under high pressure, other in is low pressure. Now, what we find that this through one the oil is coming in, through another one, another this groove oil is going out, and then there is on the body there is also connection through which the oil can either come in or come out, or in other words these grooves are connected to this passage. These passages are this one. So, these are finally connected to these chambers. Okay. Now, if we count that these channels, there are 7, 1, 2, 3, 4, 5, 6, 7. Okay. Whereas these slots are 12. So, 6 in this direction, 6 in other directions. Now, at a time if you observe, so this is completely blocked, high pressure connected to high pressure, whereas this is open, but this is connected to low pressure. Next, if we come, that high pressure is connected to, must be connected to one chambers. The next one is also connected to another chambers, whereas this is blocked, that means this slot is blocked. Next, this is also blocked, whereas this is connected to another chambers, and next this is blocked, whereas this is also connected to a high pressure chamber. What we find in this case, 4 slots of this out of 6 are connected to high pressure chambers, that must be in expansion mode, and in between 3 slots are blocked, which is in connected to low pressure chambers. Next, we come here, what we find that this slot is the low pressure slot is connected to one chamber, then one high pressure slot is blocked, then another low pressure chamber is connected to, low pressure slot is connected to another chambers, whereas another high pressure chamber is blocked. So, what we find, 2 are blocked, 4 are open, 2 high pressure are blocked, whereas 3 low pressure slots are open to 3 chambers, that must be in compression mode, oil is going out. So, this is the beauty of this valve. I do not know who invented this, but very unique design. This flow distributor valve, also known as Pintle valve, it is also called a Pintle valve, used in orbit motor, is a unique design. The valve is integral with the output rotary motion of the inner member shaft. Opposite to the output end, that means suppose this is the output end, the shaft is hollow and the houses the one end of the gear coupling type cardan shaft. The cardan shaft is connected, actually if we consider, say suppose this is the output side, just when the distributor valve is beginning, that is at the junction, there is a coupling, gear coupling, and through the hollow side it connected to the star. So, this is described here. The other end of the carbon shaft is coupled to the central spline of the inner star member. Thus, the rotation of the inner member about its own axis is transmitted to the output shaft. Now, if we look into this valve, you can see, you can compare this how this oil is going. See, these long slots through the body is these grooves. Okay. I will show also assembly of this machine where you will be able to understand. On the valve body there are two circumferential grooves which are aligned to two ports holes, which I have already described. So, if you read it, you will be able to understand what I have just described about this valve, how it is working. The uniqueness in the valve design is such that the set of transverse grooves connecting the inlet will be connected to the chambers in expansion mode, and the other set connecting to the outlet will connect the chambers in compression mode. The immediate grooves will remain disconnected. This means that there will be a sequence when one of the chamber is in neutral positions, then you will find in this case where the 6 slots are there, 3 are connected to high pressure, 3 are in low pressure, 1 is in neutral. Okay. That neutral in if it is first from the high pressure 4, then 1 neutral, 3 high pressure, 3 low pressure. Next phase it will come that 4 in low pressure and then 3 in high pressure, then one chamber will neutral, but that is momentarily. Now, here I have shown the different phases. Okay. So, you can see this what is connected to which groove through this. Here is the star and gear, and here is the valve and their connecting ports. So, if you study this very closely, the sequences will be understood. Okay. Here is also the angle is given, that what angle this was. This is the, you can say, this top dead center of a chamber, and the bottom dead, so this is the bottom dead position of the chamber. So, this the same chamber, here it is bottom dead center, here it is the top dead center, here is also at the bottom dead center. Okay. Now, how to design such a star and ring? In that case, again we consider that this is the describing circle of the outer member, this is the describing circle of the inner member. What we are trying to do? We are trying to generate the lobes or the profile, gear profiles. What we should do? We shall keep the inner member, we are trying to generate the lobe on this is the star member. Okay. So, what we will do? We will consider this member as a fixed, and then this member is rotated about this axis. That means, this is just sliding over this, no slip, and we have taken a point outside this rotating circle. Say, let us consider that this is a hollow body, that means a plate is like this and this size hole is made. Then we have taken the generating point here. If the point is taken on this circle, then we should call this is epicycloid. the generating point, if it is on the circle, we should call epicycloid. We have taken this point outside, it is called epitrochoids. Now, this curve will generate a curve like this. I mean, this point will generate a curve like this as we allow it to rotate. So, therefore, we can have this equation of this curve by only forget about this portion. First two term will give this equation of this curve, where A0 is the A0 is the length of this arm. Now, we have used a bar. This bar has been used to make this formula dimensionless. What we have done, actually, we have divided these terms by R0, which is the radius of the outer describing circle, capital R0. We have divided by that and we have made it dimensionless. This is A0 by R0 and this is R small r0 by capital R0, sorry, this R0 minus small r0 by this capital R0. This you can easily, this is geometrically easily you can find out. So, we have not considered this part. Now, so this is to show this dimensionless form. Now, what we have done, we have, as I told, that we can fix a curve at the crew nodes, and then what we will find, that we will find another profile which is parallel to this. That means, inwardly shifted, parallelly shifted this profile, and which will give the active profile, the effective profile of the star gears. And this is, as this is a constant, then this profile will be a circular arc. Now, this profile you will find that generating point will move. That means, when you are generating this curve, this can move in this direction, this will move in this directions by maximum of this angle, which is called leaning angle. It will move this side, also it will move this side. Now, to find out the equation of this point, what we do, simply we take this radius and this is in this direction, inward direction. So, minus sign is there and this is the angle, this angle plus this angle. Geometrically you can easily find out. Now, only thing, this angle is the input angle of these rotations, that easily we can find out, but for each and every point we have to calculate this angle, that is which is called leaning angle, and this leaning angle can be derived by this equation. So, this is the all known values. So, you can easily calculate what will be the this angle, and the maximum of this angle, leaning angle, this already I have shown there. So, maximum of this angle is given by this one. So, this will vary in this directions and move in this direction, also in this directions. Now, for this, each and every moment we have to find out the radius of curvature of this one, because this Rm should not be greater than this value. If this is greater than this value, then this curve, feasible curve will not be available. So, each and every moment we have to calculate this radius of curvature, which is given by this one. Okay. So, here it is specified, therefore, the radius of curvature of star profile is Rs is equal to that this is capital R minus Rm, this is the radius of curvature. So, this is the reduced radius of curvature of these points. This should be always positive. It is to be noted that this value should not be negative. The effective radius of curvature of this new profile should never become negative. It becomes negative, then this curve will not be possible. Now, to design the envelope, already I have described how this can be designed. Now, actually in actual machines we need not bother about these curves, because these curves we are not using, we are using the modified curve which has nothing but an circular arc and the center is known. This center can be easily calculated by using this formula. Then in actual design we are using the earlier formula to find this modified star profile, and we are using these coordinates to find out these points where we can put the circular arc. Only thing, between these two circular arc, whatever the portion that we need to design, in case of the separate roller, even we need not bother about that. We can take a circular arc, in that case we can make a groove and we can put the pin. In case of integral one, we have to see that tip of the star should not foul the inner chamber, otherwise it has no value. We can increase that space also, like in trochoids of gears. Okay. So, the radius of curvature of the ring lobe is equal to R m. So, this is known. If we go for stress analysis, always we should take this at the contact, the radius of curvature of outer member, that is the ring gear, is R m, whereas radius of curvature at the contact point is R s, which we have to calculate. So, now kinematic of active contacts, if we would like to observe this, let us see. So, as you can see that each and every contact point you can find out that this is the instantaneous center of rotation of this. You join this point to the center of this circular arc, you will find this contact point. So, next day we shall learn how to calculate the contact point and what is the variation of this chamber. Simply you can calculate these two contact point, variation of this length will give you the variation of chamber volume. Okay. Now, also we can observe the other as you see, this is the variation. You can see this is rotating in one directions, whereas this point is rotating in the opposite directions, and the instantaneous contact point is rotating like this. So, these will be required for the further analysis, volume displacement, stress analysis, etc. Now, the last thing I would like to show you, that assembly on the functional feature. Now, if you look into this, this is the body of the orbit motor. In that case, this long hole, that is the passage to each chamber, and you can look into a key shot type grooves through which the oil from the distributor valve comes into chamber and it goes back in the same way. You will find that 7 such long hole. As well, you will find the 7 such short holes for fixing the star ring, etc. Now, look at the distributor valve which is coming in. You can see these slots, grooves are like this, and these grooves mid position, this common portion will match with these grooves. If you look into this, this is matching. Now, this is this side cover plate with a bearing, etc. Then this is the current shaft. The other inside of this shaft there is a gear coupling. So, this is being engaged to this gear coupling, and this portion will be engaged to the star gear, and this is a groove where the oil seal is put to make it leak proof. Then you will find that this plate is called valve plate. This plate is required because there is a star is rotating. So, there is a rubbing to the main body is not suitable for this. So, we need a valve plate which we can replace also easily. Now, you can see the star is put, and then this there will be another cover plate, and then the final cover will be there. But in this case we have shown the final cover is a transparent one to see this gear inside. We can have a look, another look. Just observe this, you will be able to understand yourself how it is working. This is the input and output main connections. In case if we find that this body is being used as an output, we have to connect this input and output oil maybe through this shaft. It is possible in this shaft from the front side, which is will be held, we can make a two grooves, and that we can make a hole here and here. So, it is possible, or I mean it is not difficult. Now, look at this. This carbon shaft will go inside. Now, to maintain this, how these grooves and then the interchamber is linked. Actually, the cardan shaft, all the teeth both side the same phase, there is no lead lag, and then in the star the splines or the gears, those are made with a particular sequence. That means, one groove of this spline is matching with the bottom of this one. Say for example, in this case perhaps it is like that, this one is the center of this one, whereas it is this is the center of this one. This matching we should do to maintain this sequence. Now, there is not so what I have described, this is you may not find in any book, but if you go through these papers you will be able to understand what I have described today. Thank you.